Hello everyone. I thought it would be cool to share some sort of blockchain tutorials on how to solve blockchain challenges from a CTF point of view. So before we dive into the actual solving of the CTF problem, if you don't even know what a blockchain is, I suggest you go and read this blog. It's a pretty a decent looking blog that I did. So it gives you all the definitions of what a blockchain is, what an Ethereum is, and what is a faucet, what is a testnet, what is a mainnet, and some sort of blockchain vulnerabilities, and a lot of other things. Also, it'll give you a sort of introduction on how to actually interact with blockchains, how to deploy blockchains using tools like Foundry tools, or something like Remix. So I haven't covered Remix in this blog, but we'll be looking at this in the upcoming minutes. Okay. So there is also this video. Uh, it's a really bad video, but it gives you sort of a brief introduction to approaching blockchain challenges. But we'll be going over this once again. So the CTF in question is Wargames CTF 2024. So I guess the organizing team is from Malaysia. Pretty cool place. And let's go on to challenges. And it's a really nice interface that you can see. So it gives you um, the outline of Malaysia, I think. So this is, if I'm not wrong, that is Johor. So the one below Johor is Singapore, and probably KL is over here. And okay, these are all irrelevant. So let's go on to the blockchain category. And the problem we'll be solving today is guess it. So it's a medium difficulty problem. So in the description it says Santa Claus has been kidnapped and is kept in a secret dungeon. Can you unlock this contract and save him? Shout out this to this author. Really cool challenge. And the first thing you'll be given is the launcher link. So we'll go over to that. So the Ethernet launcher acts sort of like a uh, credential giving tool that gives a particular sort of private keys and your private wallet that you can use to interact with the blockchain that they have hosted in their RPC chain. So if all these words sound foreign to you, no worries. We all learn. And quick disclaimer: I'm no sort of advanced guy to learn from blockchain security. I'm just learning, and I'm here to share my learning. So we've also been given a zip file which I've already downloaded. It's right here, and once you unzip it, you'll be given this guessit.sol file. So the sol means that it's a Solidity file, which is the primary languages used to build and deploy blockchain mainnets or blockchain contracts. So let's look at what the guessit.sol file does. So we've been given the Solidity file that we need to analyze at first, and we've also been given this setup.sol file, which is just as the name suggests, it is a setup file which is used to deploy the contract. Okay, so it defines a contract called setup and some variables and a constructor, and it calls in the easy challenge from the guessit.sol file, and it deploys it, and it checks if the challenge is solved, and once the challenge is solved, it gives us the flag. So before we dive into this analysis of this code, let's go on to this Ethernet launcher. And before getting our credentials, we need to do one thing. So it says run the following command to solve the challenge. So you copy this command. So it's a curl command which references the website and sort of gives you sort of acts like a what do you say, like a captcha sort of thing. So it wants to be unique to every user, And so we do this particular command, paste it in and enter. So it should be quite fast, and it'll be giving out a key which we then need to input into the, okay, there it is. So we copy this and enter the solution and submit the solution. So and it says challenge solved, and then we can launch the wallet. So in this, we've been given our personal credentials, the RPC endpoint, the private key, the setup contract, and the wallet. So all the things that we need to solve the challenge will be given to us. So let's take this and store it in a notepad. Okay, we've done that, and now we can go on and analyze this challenge. So in this challenge, I'll not be going over really deep into what a Solidity code is and how it's actually written, because I'm not really that advanced. So the problem here is this particular mapping. This is the mapping and sort of thing that we need to focus on. So the thing that we're actually exploiting is the blockchain storage slots, or how a storage is stored in a blockchain. So what this particular mapping does is that it takes in a key and packs it with the block number and the message sender. So this KEKAC 256 is a hashing algorithm like AES 256. So okay, so I'm not really good at explaining things, because there's a lot of prerequisites before you actually explain things. So let me try my best. Okay, so this particular constructor function basically initializes the easy challenge contract, and what it does is that it takes in this variable, the keys and is key variable, and all these before this is just initializing the constants and variables. So this constructor initializes this contract, and it basically packs this particular variable with the block number and the message dot sender parameters. So what is the block number and the message dot sender parameters? This block number is the block number during the time of deployment, and this particular variable is the, you can say, sort of to identify the sender. It matches with a hash value. So this whole encoded this packed variable is stored as a hash value. So, and then the core of this function is the unlock function. So it takes in a slot parameter, and it's an external function, and it takes in a 32 bytes key, and this is something that we call UL. So UL is an inline assembly used within Solidity to access low level storage contracts or low level storage units. So in you can say that it is similar to assembly, but the high level Solidity syntax cannot access low level storage units to the extent that the UL syntax does to access the storage unit, if that makes sense. So it is basically used to access really deep storage units. So this particular UL syntax, it defines the assembly, and it uses some this particular storage mechanism called sload, which is again assembly thing, and it stores the key, the hash value with the allocated slot available during the time of deployment. Okay, so I really did the bad job of explaining things, but the sort of rough idea is that the challenge takes in a key which is defined here in this constant, which is lead in lead code, and it initializes a public variable called isKeyFound, and it checks if the unlock function is true, which matches the. So this unlock function is the core of the challenge. It validates whether the value stored at the given storage slot matches the hashed value stored in the keys variable. So that's all it does. So since this S load is vulnerable, we can sort of develop an exploit that that actually calculates the slot and the key. So all we need is the key variable, the key and the slot. So in order to exploit this vulnerability, we need to know what the slot of the mapping is. So this is a mapping, right? So this is the keys variable and it's a mapping from UN to bytes 32. So in order to find out the slot number, so it's already been given because if I've actually modified the original contract in order to make it easy to understand. So this is the first variable. So it's assigned the slot 0, and this is the second variable and it's assigned the slot 1. This is not considered because as a slot because it's a constant and it is not considered. So we know the slot number and also the key. So now we can develop an exploit. Okay, so there's actually two ways to solve this challenge. One is through Foundry tools, which I prefer and it's much cooler, and the next is using an online IDE called Remix, which is very popular, and we'll be going over both the methods. Okay, so first let's solve this in Foundry. So if you haven't installed Foundry, it's a really simple command. So you just do, let's copy, and this is the command used to install Foundry tools. It's really simple. So you pull in the Foundry and you install, and then you simply run Foundry up to install Foundry. You can also add it to your bash RC script, and which starts in the new terminal each session, and it's installing Forge, Cast, Anvil, and Chisel, which is all really cool tools that that is used in order to build and deploy blockchain contracts. Okay, so once we've done that, let's go ahead and create our Forge directory. So we can do that by doing Forge init and the name of the directory that you want. I'll name it guess and click on enter. Okay, waiting for it to load. So it does a lot of background things, and it initializes. It's sort of like building your Next.js app or Node.js or React. It's sort of like that. And let's go into the directory, and it actually looks like one, so the readme file and all that. So let's go on to the source directory and wipe these out, and also go on to script and wipe this out. So another heads up is that s.sol represents sort of setup script that is actually used to deploy a contract. It pulls in the contract from the source directory and it deploys it, sort of like a deployment script or a setup script. And also we have the test directory with sample test problems, which ends with .t.sol, which makes sense. Okay, so let's open up VS Code and start developing the exploit. So I'm not sure if I'm clear, but hopefully you'll bear with me and it all makes sense at the end. So let's go on to the first directory and go into guess, and under script let's name it exploit.sol. And okay, the first thing, I'll not be really clear on the solidity because I'm also learning. Here's the contract, the exploit contract after it's written, so with also some comments to understand. So the key to this exploit is understanding Solidity storage layer. So fun fact, Solidity has about 2 to the power of 256 storage units, and that's a lot, and every storage unit is about 32 bytes, and this particular slot is actually the core of the exploit. So it defines a variable called slot, and it wraps it with the hashing algorithm, and it packs both the key and the slot of the mapping, which we both know, which is 0x lead and 1 for the slot, and it packs it, hashes it, and sends it to this unlock function, and we pass in the slot as the parameter for the unlock function, and we also write a setup script for Foundry, which imports the exploit contract, and we also need the private key, which we'll be doing, and the setup address, and then we'll be deploying and running our exploit. So let's go on to the Ethernet launcher and get our setup contract. And paste it in. And your private key. Since this is a challenge, you are free to show your private keys to anyone, and you do not, of course, show your private keys to your real mainnet contract or your blockchain. So the next step is actually just running the exploit. Okay, so after some minor adjustments, we've spun up a new wallet for us, and after all the adjustments, like you input your private key and your setup address and all that, and you input the command with your RPC URL and click enter. Let's see how it goes. It's compiling, and yeah, so this is the it sets up the EVM and the gas prices and all that, and it gives you the message that the execution has been completed and is successful. So now all we have to do is just go up to our Ethernet launcher and click on flag, and there you have the flag. So this is method 1 of how you solve your Ethernet launcher, of how you solve the blockchain challenge with the Foundry tools. The second method is to solve this via Remix. So if we go on to Google and type in Remix, let's go on to Remix Ethereum IDE. It's a native IDE for Web3 development. It's really cool, but I prefer Foundry because it offers a lot more customization, and it's much easier to work with the CLI rather than some online IDE. So it's a lot to take in at first, but we'll just keep focused on whatever we set out to do. So just create a new file and name it exploit.sol, and let's paste in our exploit code. And yeah, it gives you a pasted code alert that basically you shouldn't run the code before you actually have gone through and fully understand the code. So okay, and the next thing that you do is you go on to the Solidity compiler and you compile, and seems like there's no errors here, so we'll go ahead and deploy this. So before we deploy, let's create a new, let's terminate this instance and launch a new instance. And so this is the second method that we solved with MetaMask. So you basically install MetaMask as an extension in your browser, and you go on to add a custom network, and then you define the network name, the RPC URL. So let's just open this in a new tab, expand view. Okay, so let's just delete this for now. Okay, so this is the Go chain testnet that we are currently gonna work with. Let's go on to, okay, let's add an account, import account, and your private key, which is given here, import. And once it's imported, let's create our custom network with our RPC URL. Optional is okay, add URL, and chain ID is, it's probably gonna be this particular chain ID. It's so it's currently used by the Go chain testnet. Probably do that, and yeah, and then the currency symbol is Go, and save. Okay, so we've imported the Go chain testnet, And now all we need to do is you go on to remix again, you go to deploy and click on injected provider MetaMask, and then it opens up a pop-up with MetaMask on. It's loading. Okay, yeah, and you go to edit. I just want the account 4 thing, which is the private key that we imported, we updated, and we want only the Go chain testnet that we need, and connect it. Okay, so we've connected it. Okay, so seems like there was a mistake in inputting the Go chain testnet URL, the RPC chain. So I've corrected it, and let's click on save. And now it shows it's about 0.002 Ethereum for a testnet, and that lets us transact and deploy our contracts. So once you've done that, let's go ahead and reload the site again. Okay, wait for it to reload, and hopefully all the things goes well this time. So let's go on to exploit.sol, compile it again, no issues over there, and injected provider with MetaMask. Conf4 is cool. Let's remove all these and just go chain testnet and update, connect it, and yeah, it shows that we have 2 ether actually, which is cool. Okay, and then we can go ahead and deploy our contract. Yeah, and it asks for confirmation from MetaMask, and we basically need to approve our transaction, excuse me, and confirm. And now we can see that the transaction has been successful, and we've actually deployed our contract. And the next thing that we need to do is you go ahead and copy your setup contract, and you paste in the setup contract at this particular box, and you basically do this to run the contract. That is to deploy the contract. The first transaction is to deploy the contract, and the second one is to run the transaction. So basically we transact it, and once again the MetaMask will ask for confirmation for this transaction, and we go ahead and click on confirm, and waiting for it to, yep, we see that the second transaction has also been confirmed. And now we can go on to our iSetup interface. That is to basically make it so that to verify whether that is to call the isSolve function. Let's do, okay, let's make sure that I've copied my setup contract again, and address, and over here iSetup, and let's this is basically like check in if the challenge has been solved or not. Let's click on solved, and it gives us true. So that ensures that the challenge has been solved. And let's go on to our launcher and click on flag, and that gives us a flag. So this summarizes the 2 methods used to solve this particular blockchain challenge called Guess It. It's a really cool challenge that basically introduces ourselves to the world of and the domain of blockchain security. It's really interesting field. We have a lot of tools and a lot of scripting, a lot of different things to learn from. It's pretty cool and upcoming field. And yeah, so this is introduction to blockchain security. Bye.